Good morning, everyone joining us today for our webinar on how to maximize the performance in Lightning Experience and also Lightning components. Today, I'm joined with Aditya Nag. By the way, I'm Satya Sekhar, Senior Developer Evangelist from Salesforce. So you can see the speaker screen there. And as you know, we are joined with Aditya. Hey, Aditya, how are you doing today?
Hey, Satya, I'm good. How are you? Are you staying safe?
Great. Yeah, of course. Yeah. So with that, let's get into our very first slide, which is a very important slide, the forward-looking statement. So today we might be talking about few of the concepts which may not be generally available on the platform or which may be in pilot or beta mode. So if you are planning to make any purchase decisions, please don't rely on what we are talking, rather rely on what are generally available on the platform. We are available on all the social channels. The first one which you are seeing on the screen is the Telegram channel, which we introduced recently. If you want to find the latest updates on what's happening in India and also across APAC and the important information globally as well, stay tuned with this Telegram channel. If anyone has not yet joined, so I strongly advise you join this channel and make use of this channel and keep yourself updated with all the latest updates on the platform. And you can tweet us on our Twitter handle at Salesforce Devs, and you can find more awesome webinars and the latest information in our Facebook as well as the YouTube channels. With that said, let me get into some housekeeping for this session today. During this session, you're all muted. So if you have any questions, you need not really wait until the session is done. You can keep asking your questions. We'll try to answer as many questions during the session. I'll be answering some of the questions there. And also we'll be answering most of the questions towards the end of the session. And also, please be noted that this webinar is being recorded. So you'll also find the recording of this session in the same registration link from where you registered for this webinar. With that said, this is a very important slide, I believe. Let me start by thanking all the medical, paramedical, police, supporting cleaning staff, and all the volunteers who are working day and night to keep us safe, and thus helping us win the war against this pandemic, COVID-19. Aditya, do you want to add some more points to this slide?
Yes. So I want to take this moment to ensure that all of you are staying healthy. You're staying at home and you're making sure that you're following all the security precautions that is enforced by the government. And we also want you to know that we are here for you in case you need something. And if you want to know more about what Trailhead, that our team Trailhead and Salesforce is doing to support our community, you can navigate to the link that is shown on the screen to know all about it. So stay safe, all of you out there.
Awesome, awesome. With that said, I think I have a question for you, Aditya, even before you get into your agenda and tell us about what you're going to talk about today. So have you been or have you ever done any kind of webinar like this, what we are doing today? I think this is the first experience for me. And have you done any remote webinars?
Yeah, as a matter of fact, I have done it. So my very first webinar with the Salesforce devs team was actually a remote one. At least this is better because all of us are in the same time zone. But if you can see in the picture there, I was not at all in India. So I was awake at 1 a.m. in the night for this. So yeah, this feels a lot better, even though I'm delivering it remotely.
Cool.
And that said, I want to take this moment to tell everyone that because all of us are delivering this webinar from home, we might face a little bit of a power outage or internet outage in between. So we are keeping a track of it. So in case you lose connection in between, we are tracking it and we are going to rejoin. So please bear with us in case there are any technical glitches, but most probably there should not be. We have taken all measures. So let's see how it goes.
Awesome. So with that, I think Aditya, it's time for you to take us through the agenda of today's webinar.
Yeah, so today's webinar, as you have seen in the title slide, it is all about maximizing the performance of your Lightning pages and Lightning components. It's, I think, the most debated topic of late. So in our agenda, first we're going to start with what is the difference between Lightning and Classic. Most of you probably already have faced enough interview questions on this, but I'm going to cover it at a very high level to see how is it fundamentally different. And then we are going to talk about how do you measure page performance. So it's not like you're going to have a stopwatch in your hand and you're going to measure. So we have some metrics. We are going to look at that. And then the most part of the webinar, we are going to talk about the 6 factors that are going to impact your page performance. And for each of these factors, we are going to tell you how you can measure and how you can optimize the metrics for each of these 6 factors. So that is going to be the most part of the webinar.
Awesome. So yeah, with that, I have a question, Aditya, because I was getting this question from many people about what is the fundamental difference between the classic experience and the Lightning experience, and why we should in fact migrate to the Lightning experience, and why we should use Lightning experience. I have few questions like that. Can you take us forward?
Sure. But before I answer your questions, one thing that all of us will have to make it very clear is that we heard all of you, that is everyone attending the webinar, everyone that's going to see the recording, we heard all of you very clearly that Lightning performance is not where it needs to be, that we have understood from you guys. And we are working very hard towards improving the performance of Lightning as well. So currently, the median load time of any Lightning page, we are seeing it at 1.4 seconds. Even though this might seem like a little bit of a lower number, we know that some of the customers are seeing unacceptable numbers. So we are working on that. What we are also doing is we are migrating most of the core components of Lightning Experience to Lightning Web Components. So let's take your Lightning record pages. We are slowly migrating the infrastructure from Aura to Lightning Web Components. And in our tests, already we are seeing a 40% improvement in the load time. And finally, like I mentioned before, we are investing heavily on improving the performance of Lightning. So please don't hesitate to reach out to us in case you have issues. Please post on idea forums. Please keep the comments flowing in so that we know where the exact issue is and where we need to focus on. So with that said, Satya, I want to mention one more thing. So when I was putting together these slides, what I've been scrolling down through some content, and this is a very interesting comment that I've seen by Richard Potter, where he says, Classic is certainly faster than Lex, just like DOS is faster than Windows, but we are never going back to Classic. So this, I found it to be interesting, amusing, and accurate because DOS, as we know, the command line on Windows is significantly faster if you want to copy files, move files, or do anything. But we all love using the user interface. So I think this is a very interesting analogy that I found. I wanted to put it out there. So what do you think of this?
That's really interesting because I've been using the computer system since DOS. And when I started using the Windows for the very first time, I really did not like it because DOS was much faster. Yeah, this is really a great analogy. But yeah, I would like to know more differences between the classic and Lightning experience. Yeah, the analogy is really good.
Yeah, so this is fundamentally every one of us know that the user interface in Lightning and Classic is significantly different. But is it just a UI change? So primarily, if you look at Classic, it looks like just a form with which you can read all your database entries and maybe add more entries. That is how the Classic user interface looks because it's all about the detail page, about different tabs to access different data. But when you come to Lightning and you look at the UI, it is more of productivity and the whole customer 360 that you get to achieve by adding all of the information in one glance. All of these productivity features like path and all of those are built into it. So it's much more productive. So I'm going to stop there because more than that, everyone else knows the primary differences on the UI front and how the features, it is different. But fundamentally, it is not just the UI, but the infrastructure behind Classic and Lightning is also very different. So if you look at classic pages, that is whatever Visualforce page or any of the detail pages that classic load, it is primarily server driven. What it means is that whenever you request for a page, your Salesforce server is going to generate the HTML file completely on the server end, and that HTML file is going to be returned to the client, and then it is going to be rendered on the client. So the payload that comes from the server to the client is actually a HTML file that the browser just renders, which is why it's fast, seems fast. But when it comes to Lightning, primarily it is component driven. So not a lot of things are done on the server, but most of the heavy lifting is on the client. So if you see, if you take a look at a page in Lightning, it is primarily composed of multiple components, out of which you have your standard components and custom components. And if you drill down within each component as well, you have individual sub components. Sometimes those are base components, sometimes those are other components as well. So primarily all of this is component driven, which means your server is not going to return a HTML file. It's only going to return the component definitions. It is going to return the data, and it is the client that is going to put all of this together on the screen. So primarily that is the major difference between Lightning and Classic, and you're going to see why this impacts performance.
Great. So how does this communication happen between the your Lightning component, the front end and the back end in the case of Lightning Experience?
Right.
What's the architecture behind that?
I just switched to that slide. So if you look at it, primarily each of your component or each of the components that we build, they are primarily categorized into two parts. One is the client and the server. And if you see, the client is going to process your view and the controller. So you have the HTML content and the JS content, which is rendered by the client itself. And we use XHRs, which is XML HTTP request, which is primarily a way in which the browser communicates with the server and gets the information back. So that is an industry standard, nothing to do with LWC or Salesforce at all. So we use those industry standards to make requests to the server, and the server returns the data. So sometimes your Apex controller is going to return the data, but primarily when you're loading the page, your component definitions, whatever is it that you defined, is going to be returned. So it relies heavily on XHRs and the client in order to render your page, and your server is going to only supply the required data or metadata for that. Right.
Okay. So when we compare the Classic experience to the Lightning experience, is it only the user interface change, or what are the major changes that took place, like when we in fact switched to the Lightning experience?
Yeah, so based on whatever I have shown till now, I think it's pretty clear that it is not just a UI change. Fundamentally, the entire architecture has changed. And because of this, there is an impact on performance, definitely. Because I want to read through each of these bullet points. The first thing is that your heavy lifting has been migrated from the server to the client. So in Classic, you've seen the server generate HTML, which is returned. But now your client is supposed to do all of the work of putting together the HTML, getting the required data, and creating your page. So because of all the heavy rendering being done by the client, it is super sensitive to your browser and device performance. So if you're using a low performing device or a low performing browser, there will be an impact on performance because the client sits on your machine and your browser sits on your machine. So if those two are not performing well, the client will not be able to render properly. So that is the first major impact that you have. The second one is to initially render your Lightning UI. There are multiple XHRs that go back and forth. So like I mentioned before, now once you try to load a Lightning page, there are certain requests that are sent to the server to get your component definitions, to get your layouts, where to put which component and how each component works. All of those definitions are returned by the server. And once the components are rendered, if you have access to data and stuff, then another request is going to go, which gets the data. So to initially load a page, there are a lot of XHRs that go back and forth, which is why it is sensitive to your network latency as well. So if you have a poor network, because it relies on so many round trips, there might be certain impact on your performance. Now, I would underline the word initially, because when your page initially loads, only then all of these XHRs are sent. But once you load a page and then you're just working with your component, the number of requests that go to the server are very, very minimal, because very few components change, very few data points change. So the requests are minimized. So in the long run, if you look at a page lifecycle, the rendering will have a lot of XHRs, but later on you'll see a very lightweight kind of movement between the server and client. So that is why there is a difference. Finally, and I think perhaps this is the most important part that we all need to remember, is that Lightning UI is way more dynamic and it contains way many more components than what Classic has. So in Classic, let's say you have a Visualforce page or a detail page and it's just that. But in Lightning, if you see, you are dragging and dropping multiple components across all of your layout. So obviously, Lightning is rendering many more components than what Classic is doing. So of course, there is going to be a performance difference between Classic and Lightning. And we acknowledge that. And of course, like I mentioned in the very beginning, we are working towards closing that gap so that you don't feel that much of a performance difference. With that said, again, when putting together this PPT, I was talking to a few folks, and a very interesting point of view here, that a client-side rendering application is always going to be slower than a server-side rendering application, because your browser is much faster when it is parsing existing HTML to put on the screen rather than creating the HTML to put on the screen. So ideally, if you have a HTML file, the browser just parses it and renders it, so it is faster. But in case of your client-side rendering application, it is JavaScript that is going to create the HTML and then render it. So there is going to be a bit of a difference. And the best example in our real life, other than Salesforce, that uses kind of this approach is Gmail, is what I can think of, because very similar to what you see on Lightning. So let's say you load the Lightning page and then this beautiful animation of the release mascot comes up, and then your components start loading. In Gmail also, it is the same way. You load a Gmail page, the Gmail loading icon comes, and it takes a bit of a time depending on how slow your network is, and then your mails start appearing. So pretty much the same concept, because all of the industry is moving towards more of a client-side rendering.
That is a pretty good comparison between Gmail and the Salesforce. But yeah, do we have, if you can show us an example in which I believe you can use the same component in Lightning and Visualforce? I'd like to see the difference. Do you have anything like that with you?
So I thought maybe I'll do a little bit of an experiment, seeing that we would want to compare Classic and Lightning. Let me quickly switch to Classic. I'm doing this after like a year or something.
I understand.
Yeah, this is the Classic screen. And what I'm going to do here is I'm going to load a detail page. So this is our property detail page, which if you see is taking a little bit of a time, because maybe because of my network and maybe because all of the images that are being rendered on the screen. But what you'll see, let me just load it in a new tab just so that you can see right from scratch. So yeah, it loaded pretty quickly. That is what it seems like, because it is only a detail page. But now what I'm going to do is I'll edit this layout, and let me add an inline Visualforce page to this, because let me compare apples and apples by making sure I'm loading enough components on Classic to see how it really performs. So I have this Visualforce page. Let me just randomly put it somewhere and save. So what you'll notice now is there is this bit of a blue screen that has come, and it has taken some time. Again, if I open it in a new tab to really see how long it is taking. So it's taking some time. It is trying to render the Visualforce page, and then slowly this page appears. So if you notice, if you are just using the detail page, it looks faster. But once you start adding a Visualforce page to this, it takes a little bit of a time, because your server has to compile the Visualforce page, get all of the data it requires, and then render the complete HTML. So that is how even Classic behaves. The more number of components you add, the more HTML that is required. And that is how it is. But let me switch to Lightning Experience and show you the same thing. Again, back to our Lightning Experience. And here is the property detail page. And now what I'm going to do is I'm going to add the same Visualforce page here and really look at how it performs. Any minute now. Like I said, all sensitive to network issues. So come on, okay. Yes, I have put the Visualforce page and let me save and go back. So what you'll see once the release cycle is complete, that is the release animation, you'll see that the page loaded pretty quickly. The Visualforce page is loading, it's taking its own time, and slowly the verified button or text that comes here. So basically what's happening in the page is it is making a request and getting some data. But if I refresh my page, what you'll observe is that Classic was waiting for the entire page to load, which is why you were seeing a whole blue screen and then the content has appeared. But then in the case of Lightning, all of the remaining components appeared, but then our VF page, which is taking some time, has loaded slowly. This is a concept that we call as progressive rendering. Means as and when we get the component definitions, we try to load it so that it seems seamless. So fundamentally, what you would have noticed is even with these many components, so I have the detail page, I have a Visualforce page, and some other Lightning components. What you'll see is the experience that I get as an end user is that the page has started loading and each component is taking its own sweet time, as opposed to Classic, where the page is waiting for the entire thing to happen on the server. So it's really perception is what I would say. This is your perceived speed, where if I compare it like this, if I add 2 more Visualforce pages to both Classic and Lightning, you would definitely say Lightning is faster, because Classic would take maybe 10 seconds to even start showing the page, but Lightning would show the page right from second 3, and then all the other components would load progressively. So that is a tiny little experiment that I wanted to show all of you to really compare and enforce the point that because Lightning is rendering many more components, there will be an impact on performance, which we are going to talk about in a little bit of a detail later. But really, because Classic and Lightning is different, I would rather not start comparing each and every feature between Classic and Lightning. Rather, in the remaining of the session, we are going to look at how you can improve the performance of Lightning itself. We won't be comparing it to Classic anymore. We are just going to take Lightning. We are going to take a look at the current performance, and we are going to see how you can improve the performance.
Nice experiment, Aditya. I can feel the difference. But yeah, before we learn how to measure the performance, there is a poll for the audience today. There will be a question on your screen. Your answer helps us understand more about you. So this question remains there for 30 seconds. Please select your answer. You have 30 seconds with you, during which you can select the answer.
This is a new thing we are trying.
Yeah, this is the first time we are trying anything like this, where we are trying to get in some inputs from the audience as well, so that it's going to help us in our future webinars. And also, if this works good, probably it can be more interactive as we go down the line, conducting more and more sessions there. So, or webinars or sessions, whatever, we can run this poll and get the information from the audience as well.
Okay, so is it done?
Yeah, it's pretty much yeah. So now you showed us the difference between the Visualforce and the Classic and the Lightning Experience, how these things work. But if I want to really measure the performance of the Lightning Experience, so how do we go forward? How can I measure the performance?
Yeah, so like I said, you're not going to definitely use a stopwatch in order to measure performance. We have some metrics that we can take a look at to see really how Lightning is performing. So the metric that we have is called as experienced page time. The definition, purely if you talk from a physics or a textbook standpoint, it is the time from which you start loading a page. So you click on a button or you click on a tab to start loading a page. So the time it takes from there until there is no activity for at least 2 frames. So at least 2 frames is roughly about 33 milliseconds. So we try to measure how much time it takes until there is no activity until 33 seconds. The reason we are leaving out that buffer is to account for any false positives, negatives regarding the asynchronous operations. So we just wait for all the responses to come back, and then we show you the entire time that the page has taken. So that is what we call as EPT, or experienced page time. So to quickly show you in a pictorial format, because definitions are long gone. So at the very left, you have a small hand icon clicking a page. So initially what happens is your browser starts rendering something, which is the orange box. And then maybe it sends a request to the server. So everything that you see in gray are requests that have been sent to the server. So maybe the request goes to the server, the result comes back, browser renders something else. And maybe there are multiple such requests that are happening across the course of loading your page. And the number 4 in green color at the bottom that you see is the cache entries. So not always you need to go to the network to get data. You can also go to the cache to get some data. So each of these gray boxes that you see, it's actually split into a gray thing and 2 blue bars. The reason is the gray bar is called the server processing time. That is how much time maybe your query is running, or maybe your Apex method is taking time. So how much time your server is really taking to process the request and return data to you is the gray box, which is called server processing time. And whenever you send a request to the server, you're sending it through a network. So there is a certain latency associated with that network. So when you're sending a request and receiving the response back, there is this latency. So that is why the blue boxes are on either sides. And the overall time, that is server processing time plus latency, is what is called the network time. So the moment you click and the request is sent and it comes back, it actually accounts for both the server processing time and network. Now, once your request comes back, your browser processes all of the information. It starts rendering the UI and stuff like that. That is what we call as browser processing time. It is not just the one orange box, it is all the orange boxes combined together as what is the browser processing time. And finally, whatever is the time that is taken to retrieve the cache is also present right over there. And your experience page time is going to be all of this. So right from the first click until the last browser processing time, all of it is going to become your experience page time. So you can see how it is almost like directly proportional to the number of network requests that you send. Of course, if you can see 2 and 3 are sent in parallel, so not much of an impact. So that is one of the tips that you're going to receive over the course of this presentation. But yeah, this is all about experience page time.
Awesome. So I like this color code as well, where we can see the difference between the network time, browser processing time, and sometimes it gets the data from the cache, and all together from end to end, we call it as an experience page time. That's so great. So yeah, how do you measure it and how we do it basically practically?
So pretty much very simple how you can measure experience page time. The first and foremost thing that everyone does is enable debug mode. So I'm going to show you in a quick demo, but some people who have already used it will recognize a small green color box with some numbers appear beside your profile picture. That is the EPT counter. If you enable the debug mode, it's going to come automatically. There is another way in which you can do it, which is you're going to add this parameter EPT visible is equal to 1 to the Lightning URL. And primarily, our recommendation is going to be to do this instead of enabling debug mode. Because as you know, if you enable debug mode, the Lightning framework code is not minified, and then you get more detailed error logs. So it's actually a warning that you get when enabling debug mode that says that performance is degraded when you enable debug mode. So measuring EPT with debug mode enabled is not recommended. So always disable the debug mode and add this parameter to the Lightning URL so that you get the counter. I'm going to show you in a quick demo, but that's one of the ways. The second one is the Lightning usage app. I don't know how many of you use it, but it's much more than how your logins are happening and stuff. So it shows you how each of your pages are performing over the course of time. It depends. You can also look at how your pages are performing at individual browser levels as well. So a lot of metrics are shown in the Lightning usage app. In case you want more granular details, there are also custom report types that are available, which I'm going to show you. And finally, those of your customers who have Shield enabled, you also have this event monitoring that comes as a part of it. And event monitoring is also going to give you detailed metrics. These are the event types that I've listed on the screen: Lightning page view, Lightning interaction, Lightning performance. So these are some of the metrics or event types that you can look at whenever you're using event monitoring. So should I show a demo, Satya?
Yeah, in fact, I'm eagerly waiting for your demo. I just wanted to see how to use the EPT visible variable there.
All right. So where am I? Okay. Okay. So you can just on any page on any URL, you can just add EPT visible is equal to 1 to the parameter like I'm showing. And then when you hit
only a question mark followed by the name value pair there.
It's a very, very simple parameter. So once you do that, you'll notice the green color icon that shows the time has started appearing. And once your page loads, it is going to complete and it's going to show you what is the time that the page has taken to load. And depends on how fast or quick it loads, there is a color coding. It's already orange. But let's look at how the other pages perform. So let's say I go to the Dreamhouse app, which is one of the sample apps that we have. So I go to the home page and I look at it, it is taking 3.37 seconds. I go to a different tab. It takes some amount of time. But what you'll notice is if I go back to the same tab again, it takes less amount of time because of all the caching that is inbuilt into Lightning. And that is primarily one of the most important points. I think I'll take this opportunity to mention that never rely on the result that it shows for the first time. So don't just do it once and say my page is slow. Actually, our recommendation is that you do it a couple of times. At least 4 or 5 is what we recommend. Try to load the page 4 or 5 times, get the metric and take an average of all of those metrics. And that is the average metric that you will have to consider for EPT. That is our highest recommendation. And the second most important thing to remember is that this metric varies on how you load the page. So for example, right now I'm on the home tab and I go to the property finder tab. So it's just taking 1.34 seconds, but watch what happens when I just reload this page. So when I reload this page, there is this entire animation that comes and then your component loads, and it takes a little bit of a more time, primarily because when you reload a page, your Lightning framework gets bootstrapped first. And after your Lightning framework loads, only then your page starts loading. So indirectly, what you're doing is you're also calculating the Lightning bootstrap time in your page performance metrics, which might lead to incorrect results. So as a best practice, whenever you're trying to measure the performance of a page, try to navigate to that page from a different page so that your Lightning framework is already loaded. All the framework is doing right now is loading a different page. So that gives you the most accurate metric. And as you have seen, if a page is cached, the response time is significantly lower. So when I loaded this page the first time, it took 1.84 seconds, but now it's only 0.69. So that is also an important factor to remember. Whenever you're measuring a page multiple times, make sure you clear the cache. That you can just do by hard reloading Chrome, Control-Shift-R, or whatever are the shortcuts that you use. You can hard reload it so that you know the cache is cleared and you're actually measuring the exact page performance time. So there are certain ways in which I mentioned. So you'll have to remember all of those because anything and everything you do, every step that you follow is very critical in measuring performance. Now, the second thing that I spoke about is using the Lightning usage app. So you can just go to all apps and find the Lightning usage app. And once you navigate to it, you're going to get a whole lot of metrics. But what is of interest to us is the browser metrics. So you can see the browser usage by month. And more importantly, if you scroll a bit down, the browser performance by month. And you can see the average page load time and how it varies across months. So maybe you have done certain performance improvements and you are seeing a significant decline. This is one way of measuring it. And the other one is it also shows you based on browser. So right now I've only used Chrome. So this is the only thing that is there. And what it also shows you is how many of your pages have loaded within 0 to 3 seconds. How many pages have taken 3 to 5 seconds. This is a very good metric to actually look at in order to identify what is happening. You can also drill down into page level metrics. So if you go to the page tab on the left, you can see how each of your pages are performing, what are your most viewed pages. But in terms of performance, each of these pages, how long is it taking? So my setup page, most of the times it took 3 seconds, less than 3. But in 20% of the cases, it took more than 3 seconds. So you might want to start investigating your pages, improving performance for those which are taking more amount of time. So ideally, I would not worry too much about the session record list because all of the times it loaded between 0 to 3 seconds. Now these, again, you have a lot of drill down metrics. I'm not going to get into that. But in case you're interested in creating your own reports out of this, you also have certain report types that are available. Just click on custom report type. And what you're going to see if you scroll a bit down is Lightning usage objects. So you have multiple Lightning usage objects by app type, browser. So you can create a report based on these objects and pull your own reports to measure EPT. I think those are all the ways. And what is our next slide?
Okay, so yeah, that was my question. So is it going to, do we have any factors which in fact affects this experience page time? And what are the considerations that we can take in order to measure it properly and understand what really affects that?
So we have multiple factors, like I mentioned in the agenda, we have 6 factors that affect your EPT, starting with geographical, device and client, how your org is configured, what is the complexity of your page, component architecture, and finally server processing. I'm going to get into each of these now. So let me start with geographical factors and network latency. So I think we have established that whenever a Lightning page is loading, there are multiple requests that are sent. But how long does a request take is dependent on how far you are from your host instance. So let's say the Salesforce data center that your data is hosted on is in the UK, and you're trying to access the data from Tokyo. What happens is your data travels all the way through the open internet, and if you have VPN or private networks, it travels through all of that, and it finally comes to you. So there is a certain bit of a latency associated with it. So we call this the round trip time. For example, when you're trying to access data, it takes 125 milliseconds for one round trip to happen. And this becomes very important because it affects every single request that you send out. And one important thing that everyone has to start considering is before even a request for your data is sent, both of the parties, that is your browser and the server, they need to establish a trusted connection using TCP and TLS. And TCP connection takes 1 round trip, TLS setup takes 2 round trips. So approximately if you have a 125 millisecond of a latency, it takes you around 400 milliseconds just to establish a secure connection. After that, your request goes out. So latency becomes very important in this case. Now, what are we doing towards it as Salesforce? So we are, like I said, we are working towards improving performance in every aspect. So we are expanding our infrastructure. We are improving our infrastructure to reduce these times as much as possible. So we are horizontally and vertically scaling our infrastructure. We are tuning our applications we are tuning our routers and all of that. But primarily today, I want to take the opportunity to talk about Salesforce Edge Service. When I was researching for this is the first time I heard about it, so I thought I'll put it out here. So Salesforce Edge Service is a new feature that we are rolling out to all the instances this year. Again, protected by the safe harbor, of course. And it is going to boost your network performance. And what really is Salesforce Edge? Salesforce Edge, actually what it does, it adds network hops in various locations around the globe. And how is this network hop going to help you is depicted in this diagram. So if you see the first part, where the previous example from Tokyo to UK took 400 milliseconds for the TCP connection. With Salesforce Edge, a network edge or a network hop or points of presence, many names. I'm not familiar with the networking terminology, but these edge points, edge services are placed in multiple parts. So let's say when you're accessing it from Tokyo, maybe we have placed a network edge in Japan itself. So instead of your request traveling all the way to the UK, your TCP connection request is only going to be terminated at Japan itself, and the round trip time is only 20 milliseconds. So your TCP setup happens within 75 milliseconds as opposed to 400 milliseconds. So a significant improvement in time. And these network edges are also connected to our database centers via a highly secure, high bandwidth, and persistent TLS connection. What it means is there is a persistent connection between both of these always. So not every request will try to establish a TLS connection by making that 125-second round trip. So overall, because of these edge points of presence, we are trying to reduce the network latency that you have to connect with our data centers. And this is a little bit of a jargon about edge service. There are these technologies that we use, TLS termination, that is your TLS is not going all the way through UK. In that example, it's terminated at Japan itself. And then we are caching all the content that are closer to the customer in a compliant manner. Of course, more details, please refer to the link that I've placed at the bottom of the slide for more technical details on this. Route optimization happens, so we are using artificial intelligence and machine learning to determine the optimal route that a network has to take. So when it comes to geographical and network latency, be assured we are taking many measures to make sure your latency is low. More information about this, visit that link. And if you are interested to know when is it going to be rolled out to your instance, please reach out to your customer success representative. They are going to help you out with it. Now, how do you actually measure network latency? I spoke about all of the theory till now, but how do you measure it, you as a customer, you as a developer? So you can ask your IT department to run this ping or trace route that they keep running, which shows you how many packets have been exchanged, how many packets are dropped, and stuff like that. But the most easiest way is to, of course, use the Salesforce performance test. That is, you just append speedtest.jsp to your Lightning URL. It shows you a page, which I'm going to show you in just a bit. And it's going to show you what is your latency, what is your download speed, and what is your upload speed. And these metrics are important because these are the recommended metrics that we have for an optimal experience on Lightning. Your latency must be 150 milliseconds or lower, and your download speed must be 3 Mbps or higher. And clearly, this is a screenshot that I've taken on my own system with my home network. And I can see that it is definitely not up to the mark. So that is one thing to remember. These are the recommended metrics. Now, how do you optimize it? Like I said, we at Salesforce are optimizing it, but you also have certain things under your control. So in session settings, you have this setting called as enable CDN for Lightning Component Framework. So once you do that, instead of the Lightning Framework files, there are 3 files actually for Lightning Framework. One is app.js, app.core.js, and one more thing. So those 3 files, instead of loading it from our Salesforce centers, which have that 125 millisecond latency, for example, we load it using the CDN. We have partnered with the CDN, which have networks maybe closer to you. And there is an improvement in the time it takes for those files to load. Very important thing to remember, We don't distribute your org's data or metadata through CDN. It is just those 3 files that are required to load your Lightning framework. And finally, as a developer, please make sure you are creating components in such a way that you reduce round trips to the server. So make use of caching services, Lightning data service as much as possible, because data is cached and not always round trips are made to the server. Now, this is a tiny experiment that I've done. This is my own org with my own network. Don't take this on my word for granted. So when I was putting together these screenshots, I noticed that without CDN, these 3 files have taken significantly longer. So app.js has taken 9 seconds. But when I enabled the CDN in session settings, all of these files loaded pretty quickly. App.js took 3.45. This has taken even less. But you'll notice that Aura prod has taken a little bit more time. So it's all very circumstantial. It varies from client to client, network to network. So before enabling CDN, please do your due diligence. As a matter of fact, that applies to everything that I'm talking about today. What all I'm going to tell you are just guidelines as a ways in which you can see if you can improve the performance. These are not silver bullets that will help you improve the performance right away. So that's very important to remember. With that, this is just a summary slide. So Salesforce Edge can be used on all my domain enabled orgs to improve performance, network latency. Lightning CDN, we spoke about it. So CDN is a capability we've brought to communities as well. So if you have a customer facing community and you want to load static content through CDN, it is possible. The difference being for communities, you can use your own CDN vendor as well, as opposed to the one that you have partnered with. Finally, Express Connect is again another service which helps you reduce latency when you're using a private network. I'm not going to share more details on this. Just use this term Express Connect and connect to your customer success representatives.
Yeah, thank you, Aditya, for all this information. I understand using CDN network may be helpful to improve my Lightning performance, but you were also talking about other factors that that need to be considered in order to calculate the EPT and stuff. So, what are the device and browser capability or browser level things that we need to consider while measuring this EPT?
So if you remember from my initial slides, most of the heavy lifting now for Lightning is done with the client itself. So whenever you're running stuff on the client, it is critical that your client has available resources. That is your CPU, your RAM, your memory, processing power, even hard disk performance, everything comes into picture. And more of your memory and CPU is consumed. Let's say you have 20 tabs loaded. Definitely there's going to be an impact on performance. And if you have a lot of plugins that you have put on your browser, the plugins take up CPU bandwidth, which means there is lesser bandwidth available for your JavaScript engine to start loading data and UI. So it is critical. And the metric that we use for this is called as Octane score. I think the first time I've heard about this is when I was researching for phones and all, people measured this Octane score and some other scores for performance. So technically for your browsers, it is Octane score to measure how fast your browser can perform. And to measure that, again, you can go to our performance test. And the recommended metrics here is an Octane score of 30,000, 8 GB of RAM with 3 GB available to the browser. So this is what we are going to recommend for Lightning to perform optimally. Now let me show you a quick demo. So this is the performance test page. So I've just appended speedtest.jsp to the end of this URL, and it shows all of these metrics. I click on test speed. It takes about 1 to 2 minutes. So I'm not going to run it now. I have pre-run it. And what you can see, this is the current performance that I have. So my Octane score is 22,000, latency is 262 milliseconds. Download speed and upload speed, everything looks very sad on my laptop. So maybe performance is
While you
impacted.
were running your Octane score, Aditya, I was while you were talking about this speed test and stuff, I was also running this speed test on my system as well. I think my system has a better performance than your system. So I can see an Octane score of 40,269 if you can compare it with your system. And again, for the audiences, I can say that I'm currently using MacBook Pro and the latest MacBook Pro, while Aditya is using a MacBook Air, the lighter version. So we have a different set of hardware. So he has only a 8 GB of RAM, while I have 32 GB of RAM on my system as well. So when we compare this course, I'm just currently I have 40,000 octane score and a latency of 181, and I have hardware cores. I have around 12 hardware cores, and the rest of the things are pretty much similar. I can see a very high octane score, Aditya.
Yeah, so I think let's do one thing. Over the course of this presentation, I'm going to share my EPTs with you. You share your EPTs to actually look at how much is it varying, because clearly your system is more performant. And
Yeah.
with that, here is a recommendation. So I've already mentioned that this is what we recommend, but this is what is the minimum octane scores, minimum RAM, minimum latency that you need to have. I'm definitely in the minimum category. Satya is in
Yeah.
the recommended category. But what we have noticed in our internal tests that we run is that minimum requirements result in 50% slower page load times. So even though you meet the minimum requirements, Lightning is still not performing as much as it should. So please feel free to take a screenshot of this slide. We are going to share the deck anyways, but just so that it is handy, you can do that. 1, 2, 3. You have taken the screenshot. Cool. So what are the techniques in which you can optimize? Again, a very strong recommendation from our end is that most of the times you don't need to do all of this. If your lighting is performing well, if you have achieved the required scores, it is performing okay, then you need not do all of this. Only if it is extremely bad, where you're using a very old laptop or a very old system, the network speed is extremely low, your device is functioning on, let's say, an i3 or something, only then try and do this. Again, not a silver bullet. Do this and see if it improves your performance in any way. That is, make sure your device and laptops are fully charged, because if your battery is low, the system conserves all of its resources, so performance is impacted. Make sure you're closing other applications, no plugins, no 200 tabs, just have 2 or 3 tabs. Do all of those tweaks. Pretty much very much cater to your own system and your own requirements, your own tests to look at if it is improving performance or not. But that is all about device capability.
Okay. So what are the things that we can consider while doing the org configurations?
Correct. So until now we have spoken about network, we have spoken about device, all of those are set. But now when it comes to your individual Salesforce instances, what you do can impact performance, and let's look at that. So the first thing is disable debug mode. Of course, I already spoke a lot about debug mode, not going to bore you. The second thing is enable secure and persistent browser caching. So this is a setting that all of the developers that I know disable it, because if you enable this, your components don't refresh after you develop. So you disable this, which is totally fine. But please make sure you're enabling this in production and you're enabling this whenever you're testing for performance, because this is going to impact. And one very important thing to note about this browser caching is that enabled or disabled, it is not going to impact your first load. So whenever you load the page for the first time, irrespective of this setting, it is going to take the same amount of time. Only subsequent page loads are going to become faster if you enable this setting. So that is one very important thing to remember. The third one is enable progressive rendering on communities. This is a very handy feature. And the way progressive rendering works, if you look at the screenshot on the right-hand side, progressive rendering makes sure that you can assign priority for the components to be loaded. So whenever a community page is loading, the user is only going to see the things above the fold is what we call. That means the first screen that they see is above the fold. Once you scroll, it is below the fold. So you can prioritize components to be loaded faster above the fold, and you can assign a lower priority for components below the fold. So make use of this feature so that your communities are much more faster. And those of you who are using console apps, the best thing that you can do in terms of org configuration is limit the number of open tabs. This again is a setting that you will have to work it out with your client. Look at what kind of systems they are using, test for performance with different number of tabs open, and you and the client together establish a benchmark and say, because of the desktops that you are using, you're only allowed to open 5 tabs. Maybe a different customer has more performance systems. So maybe they can open up to 10 tabs. So that is a call that you will have to take, but please make use of this setting to ensure performance is faster. Now, finally, coming to list views, I think this is an important point because I've heard quite a few comments on this saying, I'm using list views, data tables to scroll through large amount of content, and there is a lag in scroll and all of that stuff. It is, of course, expected because scrolling performance degrades based on the number of rows in page. It's definitely not because of data, because the server is going to return the data, but then the number of rows that you show corresponds to the number of HTML elements. So for each row, maybe 10 HTML elements are rendered. And for every HTML that is rendered, browser spends a lot of time calculating the styles for that, recalculating the styles and stuff. So the more number of HTML elements that you have on the page, the more slower it is going to be. And the more rows that you have, the more slower the performance is going to be. And in some cases, it is also dependent on the browser. So this is again a text that I found when I was researching this topic that says Chrome renders lists differently than Mozilla. So for example, when you're scrolling down a list view in Chrome, it still retains all the HTML elements in the DOM itself. But apparently, whenever you're using Firefox, it caches all the rows which are not shown. And then whenever you scroll towards that particular row, it adds that element back or something like that is what I've read. But because of that, all the information I want to give you is that it is also dependent on what browser you use. But in all our tests that we have seen internally that we ran, Chrome is the one that best performs, while Internet Explorer 11, no surprises there, is the least performing browser. What can you do to optimize your list view performance? Based on my description, the best thing that you can do is reduce the number of HTML elements, which means reduce the number of columns that you show. But primarily ask yourself and ask the customer, why do you need a list view through scroll through thousands of rows or 20 columns? Why do you need a list view for that? Because a user, coming from a user standpoint, you cannot really process all of that information because our brain capacity is pretty much limited. We can't look at 1,000 rows and do something. So please use a search bar. If you're trying to find targeted content, use a search bar. Try to put filters, try to create different list views for different kinds of geographies. And finally, use reports. So in our internal tests, what we have found is if you create a list view to scroll through thousands of records, and you create a report to scroll through the same 1,000 records, reports perform much faster than list views. So try to use reports, again, just a guidance, do your own research and find it out. And of course, you can reduce the number of columns. Disable inline editing if needed. So just don't disable inline editing because I said so. Only if it is extremely needed and your list views are performing really bad, disable inline editing. And remember, this is an org-wide setting. So make sure you communicate it with the customer. If they don't really need inline editing, do that. And finally, as a last resort, you can disable some browser settings to make it faster. So do I have a demo for this? Yes, I think I do. And hopefully it works because I don't trust my network. I tried to again put together a very small demo to see how it really works. So here is my leads list view. Currently, because I don't have the EPT counter, let me put it. Okay, so leads list view. Now the recently viewed list view took 3 seconds, totally because I reloaded the page, bootstrapping time, of course. But let me look at how all leads performs. All leads, it has taken 2.25 seconds because I have like 10 columns in here. But what I've done just to show you if really performance improves by reducing the number of columns, I created another list view called some leads, and hopefully the time should be slower. If not, I don't know. Yeah, it is slower. So it has taken only 1.47 seconds to load this list view. Again, it is not dependent on the number of rows because lazy loading is enabled. Every time only 50 rows load. As you scroll, more rows load. But what you see, the primary difference is the number of columns. So instead of 10 columns, if I put only 4, the performance has improved. So due diligence, do your own research and make sure it comes down. So that is what I wanted to show you about list views specifically, because this is the most sought out answer is what I saw in different communities. So with that, coming to the next topic, Satya, do you want to introduce this topic?
Yeah. So you showed the topic page complexity. I'm really when I see the term complexity, I feel it more complex. How can you define a page to be a complex page, and how is it going to affect the performance? How is it going to affect the EPT as such? Can you explain it in much detail?
Sure. So here, a page complexity is every time you create a Lightning page and you drag and drop components, that is the page complexity, and you define the component page visibility rules. That also adds to complexity. So if you have very complex rules on which page to show to which user, that also affects performance. So to put it in one single line, everything you do affects performance. So think about adding a component. Is that component really needed at that point? Because if you add that component, it impacts performance, but not necessarily in a larger way. Maybe 20-30 milliseconds here and there, but it is up to your component. Now, the majority of times, what we have seen is people try to add all the components to the page, to the visible part of the page. So what I mean by visible part is whenever your page loads, what are all the components that are loaded when the page loads? Those come under visible parts. Whatever are the components that load when you click. So for example, there are 3 tabs, and when you load a page, the content in tab 1 loads, but the content in tab 2 doesn't load. So once you click on the second tab, only then that content shows up. So those are hidden components until you look for them. So the number of visible components that you add to the page affects performance. So I've seen people just adding components, a bunch of different components on the page, very heavy. That is one thing which impacts performance. The second thing is the number of fields that you put on a detail page. So again, the end user can only consume so much, and they can only consume so much when the page initially loads. So if the user is not expecting to look for it when the page loads, it means it doesn't need to be on the page. But if the user wants to look at it and they are okay with clicking a button or clicking a new tab to look at it, then that is totally fine. So whenever you're trying to optimize for performance and designing page complexity, try to gather these requirements. So whenever you work with your customer for requirements gathering, all you try to do is say what all you want, what is it that the users need to do. But really the non-functional requirement part, that is performance, that really you'll have to gather requirements around user experience as well, saying that, okay, now when this page loads as a user, what is it that you need to do? What is it that you need to see in order to do your work more efficiently? So those are the kind of questions that you need to ask and accordingly design your page. So don't make it more complex by adding a bunch of components. And inefficient custom components, of course, that is the most problematic one, because when we create custom components, we hardly test for its performance. We put a dump of JavaScript, we put a lot of HTML, a lot of conditional statements, and then our component underperforms. So all of these have a direct impact on page performance. So please keep in mind all of these are really important. So how you can optimize, I already weaved it into the talk track before. That is, use lazy instantiation. That is, don't load everything on page load. Load it slowly. When a user clicks a button or when the user switches a tab, then you can load components. That is lazy instantiation. And the below areas are lazily instantiated, like global actions. You click a button, then the global action comes. So your component loads then, which is lazy loading. Then the utility bar at the bottom, that again loads only when you click on it. And of course, your app builder tabs. So each tab that you create The first tab loads on load. The second, third, fourth tabs, they load when you click on it. And whenever you're creating custom components, there are certain base Lightning components as well that support lazy instantiation. You can use those. For example, Lightning tab, both in Aura and LWC. It is used for lazy loading. Okay, so whenever you're trying to use tabs, again, this is a guidance only. Break up the elements on pages. Make sure the most needed information is present on the first tab. Secondary information placed on the secondary and third tabs. And when it comes to the details component, like I said, if you add more number of fields into the detail layout, it is equal to the number of HTML elements rendered, which is slower. So make sure the number of fields is less than 50 is what we recommend. If you still want to show 100 fields, just place component on a so that your initial page load is quick. Fields load. So that is a recommendation. So you have to find a balance, basically. And when it comes to related lists, of course, complex projects will have n number of related lists. And if you load all the related lists at once, maybe performance is impacted. So reduce it to only 12. And in case that doesn't work, then show the most important related list on the first tab using the related list component. And you can create another tab that says other related lists, and then you can load the remaining ones. And of course, custom components use Lightning actions wherever appropriate so that the component doesn't be put on the app builder. You can put it in a custom action. And of course, the best recommendation we have is migrate to LWC because it is much more faster than Aura and Visualforce. Finally,
this was a common question from many people as well. So we need to migrate to LWC. And the other question was, if most of the people, they are still working in the classic and they wanted to learn LWC and Aura, they are a bit confused whether to directly go for LWC or first learn Aura and then go to LWC. Maybe.
Let us answer that. Yeah, definitely our recommendation is if your project is currently using Aura and you are expected to maintain those components, you definitely have to learn. But anytime you are trying to build a new component, definitely go with Lightning Web Components because it is much, much, much faster. As you have seen, we are also internally migrating components of the Lightning Experience framework into LWC. And I mentioned this in the beginning. We try to move the record detail pages to LWC, and we are already seeing a 40% improvement in time. I have more case studies towards the end of the presentation that will push you towards LWC a little bit more.
Thank you.
So again, mobile, this is also a good feature. I think in the recent releases, there is a filter that has been rolled out that says, should this component be displayed on a mobile or not? Try to use that filter. Because if a component is not supposed to be shown on a mobile or it doesn't look good on a mobile, just hide it using those filters that are device specific. So try and make use of those. And this is again a very visual representation. A typical page that you have might contain n number of components. And you can see all of these components result in a lot of XHR requests, which makes your page slower. So our recommendation again is group components by user actions and not functionality. So I've been blabbering about user actions since the beginning of this section. If a user is expected to do something, only then put the component there. Just because the functionality dictates that the component should be there on the app builder doesn't mean it needs to be there. If a user is expected to do it, put it there. If not, move it to a secondary tab. Again, a quick demo. Hopefully this also works beautifully. So here I have the properties page. Let me go to the a single property. And here, if you can see, I have all of these different components. The page has taken 5.02 seconds to load because I have a detail component which has a bunch of images that are showing, and I have a whole lot of components here. And I really don't understand why both of these components are placed side by side because it is the same image that is being shown. And some details are being shown here. while the same details are present here. So this page is not optimized, which is why the page time is so sad. So let us optimize this page and look at how it behaves. So in the interest of time, I have already created a new optimized app builder page. We are going to set that as the auth default and look at how it works. So currently this is the property record page with a bunch of components underperforming. So I've created a new page that is called the property optimized page. And in this, what I've done is I've talked to my customer and I decided these are the only ones that they need to see when the page loads for the first time. So I've created a bunch of different tabs. So the details tab, related tab. I've created a bunch of different tabs and moved all the unnecessary components into those tabs. So let me just activate this and assign as org default. So once I do that, I go back and let us measure the page time. So those of you who have been listening attentively, this is not the correct metric because I've navigated from the app builder to this page. I didn't navigate from a list view like I did before. So I'll have to go back to my list view, make sure I clear the cache because once I loaded the detail page, it is stored in the cache. So if I go to it, it's going to be significantly faster. So I want to hard reload, which makes sure that the detail page cache is cleared. And I'm currently on my list.
Is there any shortcut key, Aditya, that you're using to hard reload the page?
I found Command Shift R or Control Shift R, but then again I forgot what is it for Windows. Just Google for it. Hard reload or cache, clear the cache and reload, those things.
Thank you.
So I'll click on architectural details now, and I see that the page is taking 3.39 seconds. Previously, it has taken 5 seconds. So I already see a 2-second improvement in page load time. So Satya, how is it for you?
It is pretty less. Yeah. For my laptop, it is around. Let me quickly check it. Give me a second. Yeah, it is 2.38 seconds.
Oh, interesting. So again, a practical proof that because of my Octane score, maybe it has taken a little bit more time, but Satya is 2 seconds, which is good, not too bad. So again, that is what I wanted to show. And because of this example, another important thing as developers and QA, both of you develop and test on different kinds of systems. So make sure you are testing for these performances on systems with similar configuration, similar Octane scores, similar network latencies, similar number of tabs that are already open on the browser. So try to make sure what we call it is comparing apples to apples. Make sure the scenario is the same and then measure for performance. That is how it has to be done. So definitely it is not a very quick thing. You'll have to invest some time in making sure your performance is better. Now with that, finally coming to the most interesting section, that is the component architecture. This is your individual custom components that you build. So there are tools in order to measure your performance of these custom components. The first and foremost, you have Chrome developer tools. Everyone uses it already. You do Control-Shift-I, you come to the developer tools and you work with it. The second one is the Lightning Inspector Chrome plugin. People who are developing on Aura, I think you are already using this, which shows you the entire timeline, what are the events that have been rendered and stuff like that. And there is something interesting called as code coverage report that Chrome generates, which shows you out of all of your components functionalities, how much of your JavaScript is actually being used. So maybe you have created some dummy functions which are not being used, so you can might as well remove those. To quickly show you a demo of these Chrome developer tools, I'll show you how really it works. So I click on inspect element. So here the use case is that I navigate to the settings tab because I've placed a underperforming component over there. And you can see this is the libs d3 component, which is taking a lot of time in order to show some information. So here it's taken like 5 to 6 seconds in order to show this chart. And the reason for that is this is how my code is structured. I load my component, and in the rendered callback, I'm loading the D3 styles, that is a third-party JavaScript. Once the styles are loaded, I'm making a call out to Apex in order to get some details from data. Once that data is coming back to me, then I'm calling initialize D3 as a function. Not necessarily the best way to do it. I just created it this way just to show you how bad the performance is going to be. So now I do this, and I need to go to the performance tab. And what I need to do here is I need to record the performance for this particular page. Again, like I said, I already loaded this page, so I need to come back to it. And I need to come back to it after clearing the cache. So I come to the home page, I reload, and after some time, once the page loads, yes, the page has loaded, the cache is cleared. So let me quickly click record, and then I'll navigate to the settings tab. And what this is going to do, it is going to wait until the component loads. You are also going to wait. So now that I see the output, I click stop. So what exactly it is doing, it is recording performance of your entire page load over the duration of your record. And then it's going to show you this beautiful little graph. Now, there are certain things, this might look overwhelming at the beginning, but what it shows you is out of all of the time you have recorded the page, what was your page doing? So your page spent almost 3 seconds scripting, which means it was executing JavaScript. And then it spent around 1 second rendering because I'm using a third-party JS, which is doing a lot of rendering on screen, heavy rendering. It has taken this much time. And it spent around 6 seconds idle. So why did it spend time idle? Maybe because it was waiting for a network request. So how do you look at that? So here, let me zoom in a bit. So here you can see the network tab where you can see all of the requests that have been sent over the course of this performance test. So you can see in the network tab that a request has been sent to load the third-party JavaScript, which has taken 1 second. Ideally, you can reduce this. And then there is this long running Apex. So you can hover over it and see that there is an Apex action that executed for almost 6 seconds, which is why your component was so slow. So that is one thing that you need to look out for to see how many of these network requests are going out and how many of these are going in parallel versus sequentially. Our goal is to make sure your network requests are going in parallel. If you use n number of wire services, we send out requests in parallel, so you need not worry about that. It's just that in your code, don't call one function after the other unless it is really required. So you do this, but I see in this graph on the top, all the orange markers are JavaScript execution, purple markers are rendering execution. So I see that once my data has come back, there is a lot of JavaScript that has executed. And let's look at how that is. And for that, you need to go to the main tab. So let me collapse the network. So the main tab is going to show you the entire execution that is done on the JavaScript thread. One important thing to look for is the depth of this chart. So this is what we call as the flame chart. And the more deep the flame chart is, the more performance is going to be impacted. So you'll have to start looking out for the deeper parts of this flame chart and try to fix those. So how do you understand this flame chart is, so let's say I zoom in a little bit on this particular frame. So here, right at this time, my data has come back from the server, and then the ready state change, etc. Ready state change is generally executed immediately after you get data from the server. So after that, you can see it called initialize D3. So if you remember from my code, that is the initialize D3 function that is called here, right after you get the data. So you can see the function call and how long it has taken. And what you can see even below that is as a result of this function call, how many other functions have been called is what you can see. That is what is a flame chart. So initialize D3 has called all of these functions, each of which has taken some amount of time that you can view here in the summary tab. You can also look at the call tree to look at XHR ready state. It called microtask, it called this, and it called initialize D3. So this is a tree of execution. So your function didn't just execute, it called a bunch of different functions, and you can see which file as well. Now, this is not a very simple thing to just talk about in 5 minutes. So you look at this, and what you do next is you analyze why is this function taking so much time. In case your function is executing in 2 to 3 seconds, then maybe there is a performance issue in that. You'll have to look at that particular function and then work with it. So that is how your flame chart can be useful. Look at the execution stack, whatever is deep, start improving performance of that stack. Look at which functions are taking a lot of time and improve the performance of those functions. So that is how you can use performance. I know it might seem a little bit overwhelming at first, but given the time we have, I think that is the best we can do. And I know, and I apologize that we are already way over time, but we figured, given that performance is a very complicated topic, I will not rush it in spite of taking more time. So I prefer to take more time instead of rushing such a complicated topic. So I apologize for all of this delay. Just bear with me for like 5 to 6 more minutes, and then I'm going to share you some tips in these 5 to 6 minutes, and then we'll wrap it up.
Yeah, thanks for that, Aditya, because I'm seeing some questions there and people are really interested and they're coming back with their questions. So that indicates that they are really concentrating. We are really sorry that we are getting a little overdue, but it definitely helps.
So you've measured the performance. Maybe we'll write a blog post sooner or later about that in more detail. If all of you request for it, why not? So coming to improvising tips. So here I have a bunch of recommendations. The first and foremost is conditional rendering. So the Aura if true, I don't know if it is Aura if true, it is Aura if, and the template if true directive. So both of those you'll have to use in order to conditionally render. Please don't use JavaScript in order to hide and show elements, and please don't use CSS. Now the primary reason I ask you not to use CSS is because CSS merely hides and shows a component, but the component is already rendered. But if you use Aura if or these conditional rendering, the component itself is rendered only if required. But with CSS, all of your components are rendered and you're only using CSS to hide and show them. So which is internally an impact on performance because your DOM tree contains all of these components that the user is not seeing, but are already loaded, which means your performance is degrading. And don't use JavaScript for DOM manipulation because primarily the first point that I told you is that your client-side rendering is always faster when HTML is parsed instead of JavaScript doing it, which is why these directives, these conditional rendering is going to do it at HTML level. It's not going to use JavaScript, so don't use it. And high number of HTML elements, of course, number of HTML elements corresponds to page load time. Very important. Now, since many people are still using Aura, I thought it is best if I give out some Aura tips as well. So if you want to render conditionally a large number of components in Aura, please use dynamic component creation. So there is a Dreamforce talk on this where they have shown a very complicated data table which contains like 2-3 depths of Aura iterations. And in the last component, they were rendering a few things conditionally. So instead of rendering it conditionally, once they use dynamic component creation, it has improved the page performance by 50%. Please take a look at that Dreamforce talk. I don't remember which one it is, but just Google it. That is why I put out this recommendation. Again, it is just a guidance. You are supposed to do it both the ways, do conditional rendering and do dynamic component creation, and you yourself test the performance of your own component and then make a decision. Again, compare apples to apples, please. Now, fix performance warnings in Aura. So these two are the warnings that keep coming up in your console, saying that you have clean unrendered body, you have to clean unrendered body and multiple items. So this happens, so let's say you have created a conditional rendering. So you're setting it to true, and then to false in the same cycle. That means maybe you have your init handler in which you are initially assigning it to true, and then you do some operations and then you decide, okay, I want to make this false. So that kind of a thing. So changing if true to false in the same rendering cycle gives this warning. And the same thing happens with for each, that is the aura iteration. It is my bad, it doesn't happen for each, only for aura iteration, where you set a bunch of items, and in the same rendering cycle, you again try to set another bunch of items to the same aura iteration. So this is what is called multiple item set, and this degrades performance. And I'll update the slide, but this happens only with aura. It doesn't happen with LWC. So this performance degradation is very specific to aura, which is why when you migrate to LWC, you might not really see this warnings. Another coin in the LWC bucket. So again, use caching features whenever possible. Your Lightning data service, your wire decorators, using the platform cache. Make sure you're not making round trips to the server as often. So use caching. Again, lazy instantiation, we spoke about it. Please use it where you use pagination or tabbed approach or use base Lightning components. All of these are lazy instantiations. And avoid creating components until the user clicks for them, which is a way of saying use tabs, use global actions, use base Lightning components and stuff like that. And finally, remove any unused CSS and complex selectors. So you would have seen in the performance chart that the browser spends some amount of time rendering. So this rendering becomes more complex if you have complex CSS and you have created a bunch of CSS that is not being used, but the browser still calculates those styles. So please optimize your code to remove unused CSS and unused JavaScript. The Chrome code coverage tool is going to help you with it. And this is again a very good tip that I found out. So whenever you're using Lightning out, what I've seen people is they create a lot of aura dependencies. So for every single component that they're using, let's say Lightning button or a custom component, they put dependencies for all of those. Definitely not a best practice. It impacts performance. You'll have to only list the top level components and expensive to create components in dependencies. So for example, the Lightning button, because the framework already knows how to do all of it, you need not really add it as a dependency. All you need to do is only add those components which are expensive to create, which is when it takes it as a dependency, it prefetches the component and it caches it and stuff like that. And finally, just like you have done with the app builder, optimize everything for mobile. Please make use of these conditional statements, $browser.isPhone, and in Lightning Web Components, you have the form factor. So use these components and optimize your images primarily for mobile. Put conditional statements and load the smaller files when it comes to the mobile in your component. I think this tip you guys have heard enough, that please don't use iframes a lot, use them sparingly, and minimize frequent navigation. As you have seen with my performance tests, whenever you do a hard navigation, that is, whenever you navigate and you find that the release animation cycle is happening, that means you're not navigating properly, which means you're trying to reload the Lightning framework again. So please navigate correctly, and if possible, minimize all of these expensive navigations. So let's say you're showing a component, and for each of the component that the user sees, they need to navigate to a different page to view more details. That is bad. So maybe refactor it so that you put the component here, which loads lazily itself without having to navigate. So stuff like that. Make sure you minimize extensive navigation and navigate correctly. Make sure the tab switches. Make sure you don't do window.reload or window.location.href. Those are highly discouraged. And whenever you're migrating stuff to LWC, we talk a lot about migration, but whenever you're migrating, migrate entire component trees. Don't just migrate one single or a component and say, I'm not noticing a performance difference. It might be minimal, but if you migrate entire trees, you can see the impact. As a matter of fact, we have already done that with one of our sample app, which is Dreamhouse. So when we migrated all of the Dreamhouse components from Aura to LWC, you can see this particular page. It is tiny, but Aura has taken 3.08 seconds while the same components, once we migrated them to LWC, it has taken only 2.04 seconds. So it's a significant improvement after we migrated all of the components. And there is a detailed case study, which we have written in a blog. You can read more in that blog, but here is just a summary. For each of these pages, we have noticed a significant improvement in performance, and you can see it's not the same. Depending on the complexity of your component, sometimes you might only see a 2% improvement, but sometimes you might also see a 63% improvement. So it is totally how complex is your component and how effectively you are migrating it. So I think that's all. A lot of blabbering has happened, and feel free to report issues. So whenever you're measuring for performance and you optimize your components, but you still feel the performance is bad, please raise issues with us. So recently, we have fixed this issue, which is a memory leak in Lightning Console. So we are actively looking at ideas, idea exchange, and all of that to see what we can prioritize.
Awesome, Aditya. It was a lot of information. So we have another poll for the audience at this time. There will be a question on your screen again. Your answer helps us understand more about you and how you understood this session particularly. So please answer this question.
If you are still there, if you have not dropped off already.
Yeah.
Okay.
I can see some pretty good results popping up on my polls window, Aditya, like which is currently around 60, more than 60% of the people are using the Lightning usage app, which in fact went 55%, yeah. And 33% of the people are already using EPT counter and Salesforce performance test and performance timeline chroming is being used by almost nearly 50% of the people, and code coverage tool is a little new tool for most of the people, and they are only 31% to 32% are using that.
Okay, that's nice.
Yeah.
So people
and
joining
we are getting some votes further. Yeah, because it's for 30 seconds. Yeah, we are still collecting few more responses, but yeah, this is what on an average. So we have 56% people using the Lightning usage app. That's great.
Okay, that is nice. We will work with these metrics and we'll see what we can do about it.
Perfect.
For further,
yeah, you can go ahead.
Yeah, please work on this Trailhead module for further learning. I think what all I have said is already covered in this module, and a little bit more detail with more reference links. So please go through this module to learn more.
Yeah.
And we also have an webinar. Satya, do you want to cover that?
Yes. So exploring sample applications is definitely a great way to learn new languages, frameworks, and platforms. For those who don't know what are sample applications or the sample gallery, join Shashank, Aditya, and me in our next interactive webinar on sample gallery, where we'll show you how to make best use of sample applications in your day-to-day development projects. So the registration link is already open for you to register for this webinar. Yeah, with that said, I believe we are really ran out of a lot of time. So we'll take only a couple of questions in our Q&A. So I try to answer we try to answer as many questions during the session. So we have few answers left out. Aditya, so one question for you is, what will be the rendering nature of pages if we use Lightning components inside Visualforce page?
Visualforce pages by nature, I think they are rendered on the server, but then when you're loading a Lightning component in a Visualforce page, it again happens on the client itself, because the entire script that you write, that is $a.create component and stuff, that is a script, so it runs on the browser itself. So yeah, it is again impacted by all of the metrics that we spoke about.
Okay, I have one question from Yuna Zhang. So for the image, is that possible to set the height and width to a fixed size?
You have, I think, base components for Apex image. No, that was Visualforce. I can't remember anything on top of my head, but I think if you want to set height and width, the best thing is to do it with CSS. You can create a class, define a height and width, and put it. But really, setting height and width is not optimizing an image, because if an image is 3 MB and you load it, but you're only showing it, let's say 50 by 50 size. So setting it with CSS doesn't really improve performance because 3 MB file is still loaded. So when we mean optimize images, it means reducing the size of the images as such. So there is such a thing as the image size and image resolution. So 50 by 50 is kind of your resolution of the image, is what you're trying to show on the desktop or mobile. But the image size, that is 3 MB, 5 MB, is what is more impactful. I think there is this utility that I use called Tiny JPG and Tiny PNG. There is this panda on the UI. So you can use that site. If you put an image on it, it is going to optimize it. It is going to reduce the size by roughly 60%. You can use that tool in order to optimize the size of the image. Again, resolution of the image is totally what you can do with CSS.
Definitely that helps. So how does chatty applications perform in case of Lex and Classic?
Sorry, what
Like
applications?
So chatter kind of applications, will there be any difference when we do it in the Classic versus like Lex?
I think I've already read some news about this, I think internally or externally, I don't remember. But apparently Chatter has also been moved to Lightning Web Components, and it has seen a significant improvement in page load times. But yeah, that is, hoping I answered that question. I don't really still understand Chatty, but definitely you have our Twitter handles. You can find us on LinkedIn and Twitter or Success Forums. Definitely reach out to us there, and we are going to help you out with it. So Satya, I think we'll take one more question, and all the others, please reach out to Satya offline, and then we are going to help you with it.
Okay, I have one last question. How can I measure a quick action load time?
So quick action load time, if EPT is not able to measure it, definitely use the performance timeline, because like I showed you, it is going to show you the event. So event click is going to be shown in orange. So the moment you click on a quick action, it's a button click. So that will be captured in the performance timeline, and then the entire network time, the rendering time, and all of that will be measured. So you can use the performance timeline in order to measure your performance. Yes.
Thank you so much, Adya, for taking the questions and for such a long webinar covering all the topics as we planned. With that said,
everyone. I want to quickly apologize to everyone again for taking this long. I mean, Satya and I knew that this webinar was going to be longer than what we imagined, but because we didn't want to rush a lot, sorry for taking this much time, but I really hope that this was helpful, because all of this content in one page, in one place, I didn't find it in a lot of places. So I definitely hope all of this is helpful to you guys, and sincere apologies for all the delay.
Yeah, and at the same time, so you'll be receiving a survey email. So please send your feedback, which is definitely going to help us to improve our webinars down the line. With that said, thank you all for giving your time and learning these concepts about the performance of the Lightning. With that said, I'd like to, we are at the end of the webinar. Thank you so much.
Thank you, everyone. I think everyone is so happy looking at the thank you slide. So
yes.
Okay, thank you guys. Bye-bye.